Okay, so now let's go ahead and let's do the second example that I have for you. The second example has 3 parts, so it's a little bit more complicated. Okay, so I'm going to read the problem. It says a hot air balloon is rising vertically in the air with a constant speed of 6 meters per second. A teenager inside the balloon decides to throw his book bag down the instant the balloon is 35 meters above the ground. And then we have 3 questions. Okay, so the first thing you do in any physics problem is read the problem. The next step that you do is assign your direction. In this case, the balloon goes in an up and down direction. This is the y direction, so I'm going to call the up direction, I'm going to call it the positive, and I'm going to call the down direction the negative. Okay, and we need this because vectors have a direction. Okay, the next step is to draw a picture, which I already did for you. So this is the air balloon. Okay, and the air balloon is 35 meters above the ground. So the initial distance is 35 meters. And we know that the balloon is going up at 6 meters per second, which is what it says here. 6 meters per second is the velocity of the balloon. And this is the book bag that the teenager is throwing down the balloon, and it's going to hit the ground. So we have to figure out a couple of things here. The first thing is we have to figure out how fast is the book bag moving as it hits the ground. So at first this problem looks a little complicated because I mean the only given that you really have is the height of the book bag. We know that the book bag was thrown from a height of 35 meters. So aside from that, we really don't have anything else. And this is what throws a lot of students away from physics problems, and this is what confuses them. You see, the balloon is going up at 6 meters per second, but remember that the book bag is inside of the balloon. So if the balloon is going up at 6 meters per second, so is the book bag. So that is the initial velocity of the book bag, and this is where a lot of students get thrown off. It's like saying if you're driving a car and the car is going at 30 miles per hour, then you think, well, you're not moving, you're inside the car. But technically you are moving. The car is moving at 30 miles per hour, and so are you. You're also moving at 30 miles per hour. It's just that you don't notice it. That's the same thing that's happening here. So this initial velocity is the velocity not only of the balloon but also of the book bag. And here we have the initial height, which is 35 meters above the ground. Okay, another thing that is not given in the problem, but physics students must know it, is the acceleration in the y direction. And what is the acceleration in the y direction? That is gravity. Gravity is pulling down the book bag towards the ground. And you need to know the acceleration of gravity, which is about 9.8 meters per second squared. Now, one thing that you should notice is, remember vectors, and remember we assigned that up was the positive and down is the negative. So because the acceleration is pulling the rock downwards, then we have to say that this is negative 9.8 meters per second. Okay, so that's another very, very important thing. And one more thing that is not given in this problem but a student should know is that if this book bag is being thrown from a distance of 35 meters, then the final distance, which is down here where the ground is, the final distance is 0 meters. Okay, so this is not given in the problem, but by the picture that you draw, you can actually figure it out. And this is the other given. This is the final position, which is 0 meters. I'm going to write that down. Okay, so now we have all these givens, and now we can actually use one of the kinematic equations because the problem is starting to look a little bit better. So which kinematic equation can we use? Okay, I'll tell you. The one that we can use right away is this one. Vy squared. And now I'm using y because the balloon is going in the up and down direction. This is no longer in the x direction. So Vy squared is equal to V initial in the y direction squared plus 2ay y final minus y initial. Okay, so we can use this equation to find how fast is the book bag moving as it hits the ground. So this question, choice A, is asking for the final velocity. So when the ball hits the ground, what is the velocity which it's going to hit the ground? So it's asking for this, the final velocity. So I'm going to write this down. Okay, the initial velocity of the book bag is 6 plus 2 times the acceleration. The acceleration is negative 9.8 meters per second squared. Okay, the final position, or actually, yeah, the final position would be 0 because it's starting up here and ending down here. So the final is 0 and the initial is 35. Okay, so this is just a calculator problem now. Let's see what we get. Okay, so now we have 6 squared plus 2 times negative 9.8 times 0 minus 35, and we get 722. So here I'm going to write 722, and to solve for the velocity in the y direction, you have to take the square root of 722. So the velocity in the y direction is equal to the square root of 700, the square root of 722, that is 26.8. So I'll just round to 26.9 meters per second. So what this means is that when the book bag hits the ground, it's going to hit the ground with this velocity, 26.9 meters per second. Okay, I'm going to stop this video here, and in the next video I'm going to do part B of this problem. Okay.